Today we're going to talk a little bit about thermal shunt issues with monitoring air temperature, or any fluid temperature for that matter. I had a customer call in, and he had this little oven that he built, and he was putting sensors through the backside of this, mounting them from the backside of this block, metal block, and measuring the temperature inside of this. And when he went to go confirm the temperature measurements, so here are sensors coming in from the backside. He put a sensor in from the front, and they were measuring 10 to 15 degrees centigrade difference. And he was wondering why that was. And so what we're showing here actually is, we want to talk a little bit about, is a thermal shunt effect. What's happening here is the diameter of this sheath is touching this metal conductor of this quote-unquote oven. And this metal sheath is either drawing energy away from this sensor, or it's imparting. If it's hotter, it's putting energy in. And there's a general rule of thumb that says that when you're measuring fluid temperature, your insertion depth of your sensor should be at least 10 times the diameter. So either there's a couple things that we can do to solve this problem. The first thing that we could do is we could thermally isolate this sensor from the block. And in this case, we've got an insulator here, and the sensor is going through that, and the idea is to isolate this sensor itself from this metal part so that the heat transfer can't occur from this metal block into the sensor itself, and we're just monitoring the fluid, which is air in this case, that temperature. Or, more preferably, we would just shrink the diameter of the sensor. So again, what we're looking for is the diameter of the sensor can be, should be 1/10, at least 1/10 of the depth. And obviously, it's a lot easier to change the depth inside of the fluid as opposed to the diameter. But if you're limited with the diameter of your fluid flow, like in a pipe or something like that, you need to use a fairly small diameter sensor. And obviously, you could do both. You could shrink the diameter of the sensor as well as putting it through a thermal isolation insulation block from the top to the bottom. So again, the idea is to eliminate or reduce the effects of thermal shunt. You want to have your insertion depth of your probe at least 10 times the diameter of your probe. So yeah, that's the general rule, and I hope that serves you well. If you have any questions, just give us a call or visit us at IES Technical Sales, and we'd be happy to help you out.